Hi, this is a tutorial with working with MCP servers and particularly integrating them with the event stream store cross.stream. So the beginning of the tutorial just starts with poking at an MCP server on the command line, which is kind of like how you start most projects when you're working with cross.stream. So we'll take this command here, which uses npx, so Node.js, to run the Anthropic example MCP server, and it's kind of like just a kitchen sink example. So we'll copy this to be able to run it and come down to a terminal. Okay, so we're now running an MCP server. And so, like, what is an MCP server? There's kind of two flavors, but the flavor we're looking at here is a standard I/O MCP server, which means in order to send commands to the MCP server, we send JSON RPC to the standard in of this little CLI process, and then we'll get responses back from the MCP server. So here we go, we're going to call the tool list method on the server. And that's kind of it. We now have, on the send out of the CLI, this big pile of JSON which lists everything this MCP server is capable of doing. And so one of the things it can do is it has an echo tool built in. And so we're going to perform a tools call. We're going to call the echo tool. We're going to pass the arguments hello from the terminal. Okay, and so we're just going to paste that into the standard in of the CLI. And we get standard out, echo hello from the terminal. One of the other tools that this example has is a math tool. So tools call, and we're going to call the add method, and we're going to add two numbers together, paste that into standard in, and we get a response on standard out. So that's it. That's what it's like to. That's all an MCP server is, and it's kind of like, yeah. And so when you're using cross.stream, usually you're poking at something on the command line. You're getting an experiment to work, or just running something, getting a feel for how it works, and you're like, okay, I get how it works. Now let's wire it up and do something interesting. And so around about then, you'll begin to integrate it into cross.stream. So the cross.stream has gives you a bunch of tools to work with. The tool we're going to use for this is a generator. So what a generator does in cross.stream. So first of all, before we actually get going, we're going to set up a monitor on the stream. And that way we can, as we emit frames into the stream, we'll be able to just see them appear and see what's going on. So what this command does is it does a .cat -f, and in cross.stream, .cat cats the stream. So we'll see every event that has ever been emitted to the stream, and then the -f means follow. So as new frames are added to the stream, our subscription will instantly get those frames. And then for each frame that comes in, so cross.stream is the core content for each event or frame that's emitted is stored in a content address store. So for every frame we see on the stream, if it has content, we'll look up the CAS, the content address storage, with the content hash, and then if it doesn't have any content, we'll just work for the frame as is, and then this will print the frame, and we'll use table -e, which that'll make the frame look good. So let's run this. Come over here to the second window. Okay, we'll run this, and so just begin. So we just see when cross.stream starts up, it emits an xs.start frame, and then when you run .cat with -f to follow the stream, when you get to the end of the replay, you'll receive this access threshold event, so you know you've caught up to real time. Crossing the threshold. Okay, so yes, now we're wanting to stream. Okay, yeah, so we're going to wrap the MCP server. So we're going to create a generator. So to create a generator, you pipe a new shell record into the event stream, and you append to a .spawn event. So when you append a frame that the topic ends in .spawn, everything that's before the .spawn will be the name of the generator. So this is going to create an MCP generator. So to run the generator, we're literally just going to run that CLI command we're playing with manually, and then we'll pipe it through the new shell lines. And so what that does, it provides framing. So when you're working with streaming data, usually you need to frame it in some way, so you can distinguish like distinct packets in the stream. So this is going to say, so every line of output coming from the CLI, from this Node.js command, is going to turn into an event. It'll turn into an MCP.receive event, and we're gonna run this generator as a duplex. So that means so you can have non-duplex generators. You just receive events as they emit output on their standard out. With a duplex, you're able to send things into the CLI command on its standard in. So anything we send on this any event MCP.send we put on the stream, that's going to go into the standard in of the CLI command. So let's start our generator. So we're going to append MCP.spawn. Okay, and if you look over here, you can see the MCP.spawn frame, and then the cross stream has now picked us up and is running this command. So we now have MCP.running. Okay, so now we can just use it the way we were using it when we were running the MCP server manually. So we can list the tools that are on the stream. So we're going to do append a MCP.send event. Okay. So now we can see on the event stream. This is the frame we emitted with the tool list commands. So that went into the standard in of the CLI tool, and then here is all of everything this tool is capable of doing, which is quite a lot. Just the kitchen sink example. Okay, coming down. Let's try. Oh yeah. So now we can actually let's do a tools call. So we're going to call a tool on the MCP server. So we emitted an MCP.send event, and then we got back an MCP.receive event, and here's the response from the MCP server. Echo hello from cross.stream, and now we can call the math tool. So we'll send an MCP.send event, and then we get back the sum of 100 and 200 is 300. Great. So the idea then is, okay, so we've kind of like composed like the CLI tool, and so we've turned like a CLI tool into a server, and so now we've kind of composed that onto the event stream. But now that we have this just running on the event stream, we can then start composing it into larger workflows. For example, we could create a cross-stream handler that watches for responses coming from the MCP server. And so the nice thing about working with an event stream is at any point you basically get to pause the application and inspect the data at that point. So we're going to like add a handler that responds to MCP to responses from the MCP server. So it's like, okay, well, what do responses from the MCP server look like? And so here's our event stream. So the last thing that's on the event stream is the response we got back. The sum of 100, or 100 plus 200 is 300. So what we can do, we can go .head mcp.receive, which will pull up the most recent mcp.receive. And so then we can retrieve the content of that frame from the content address store, and then we pipe that through the new shell from JSON, and so we can see the contents, and so we can kind of see like, oh, okay, we can see how to work with this. We can go get, and then results.content, and then okay, contents a list, and then we'll get the text. Okay, so that's kind of like, okay, that's how we unpack the response. So okay, so let's make a handler that looks at that. So here this is a new shell handler, and so handlers are different. So to create a handler in cross.stream, it's similar to you just provide a new shell closure, and so generators are things that just are running all the time. New shell cross.stream will take care of spawning the expression you give it, and to take care of keeping that running for you. Handlers by default just aren't running at all. But then for every frame that's emitted to the stream, a handler will get a chance to run, and it'll be past that frame, and then you can take whatever action you like. So this handler, it takes a frame. If the frame's not an MCP.receive event, it just returns, and so nothing will happen. And so then it kind of like unpacks the frame, and we kind of like, we know what to do because we just did it manually. Okay, and so we need the handle to do something. Guess what this handle is going to do is look for the number 42, and when it sees the number 42, it'll emit a new frame to the stream, meaning of life detected, and then we're going to append this to the stream as meaning.detector.register, and similar to generators, anything that ends in a .register will create a handler of this name. So this will create a meaning.detector handler. So we'll append this to the stream. Okay. Oops. So this is our register event, and then we'll get back meaning.detector as active. So that just that means it was able to pass the new shell closure we gave it, and it's now active and ready to receive new frames. So going forward, any frame we append to the stream will go through this handler. Okay, so let's redo our tools call to the add tool. Okay, and so we're going to do the math tool, the add tool call. So coming over here, this is we emitted this mcp.send, and the MCP server gave us back this mcp.receive. The sum of 21 plus 21 is 42, which tripped the handler we just added, and so we get a meaning.detector.out, meaning of life detected. And so that's it. That's pretty much it for this tutorial, and there's a little bit more to the tutorial, but once we are finished with that, we want to shut down the MCP server, we can just emit mcp.terminate, and then we'll see that the MCP server is shut down. Have a run through of the tutorial and see what you think. Okay,